Hello everyone, welcome back to my YouTube channel Technical Civil Orbit. Today we are going to discuss strength of riveted joint. The joint offer resistance against the various types of failure. The maximum force which a riveted joint can withstand without failure is known as the strength of joint. The strength of the joint will be taken least for the following: tearing strength of plate, bearing strength of plate, and shearing strength of plate. So what strength of rivet is? स्ट्रेंथ क्या है रिवेट की? जो मैक्सिमम फोर्स हम एक रिवेट जॉइंट पे डाल रहे हैं, जिसको वो विथस्टैंड कर रहा है, जिसके अगेंस्ट उसमें कोई फेलर नहीं आ रहा है, दैट इज स्ट्रेंथ ऑफ रिवेट जॉइंट. मतलब उसकी जो कैपेसिटी है, जो लोड को रेजिस्ट करने की, लोड को सहने की, दैट इज स्ट्रेंथ ऑफ रिवेटेड जॉइंट. तो स्ट्रेंथ को हम किस तरह से कैलकुलेट करते हैं? हमें टीयरिंग स्ट्रेंथ, बियरिंग स्ट्रेंथ और शीयरिंग स्ट्रेंथ ऑफ प्लेट, ये तीनों चीजें हमें कैलकुलेट करनी है. और जो लीस्ट वैल्यू होगी दैट इज स्ट्रेंथ ऑफ रिवेटेड जॉइंट. तो सबसे पहले क्या है? टीयरिंग स्ट्रेंथ ऑफ प्लेट, दैट इज पीटी इज इक्वल टू sigma AT into P minus D into T. Here sigma AT is equal to allowable tensile stress in plate, P is equal to pitch of the rivet, D is equal to gross diameter of the rivet, and T is equal to thickness of the thinner plate in lap joint and thickness of main plates in butt joint. तो जो ये बेसिक टेक्निकल टर्म्स है, पिच, ग्रॉस डायमीटर, ये सारी हम अर्लियर वीडियो में डिस्कस कर चुके हैं. तो अगर आप ये टर्म्स आपको नहीं समझ आ रही हैं तो आप वो वीडियो चेक कर सकते हैं. नेक्स्ट, बियरिंग स्ट्रेंथ ऑफ जॉइंट, दैट इज PB इज इक्वल टू N into sigma PF into D into T. Here N is equal to the number of rivet per pitch length. Number of rivet per pitch length. What per pitch length is? Per pitch length, here one pitch is defined as the number of the rivets which can be seen in the cross section of joint. तो हम क्या है, जो जितने नंबर ऑफ जॉइंट, जो जितने नंबर ऑफ रिवेट्स हम यूज कर रहे हैं जॉइंट के लिए, दैट इज per pitch length. And sigma PF is equal to allowable bearing stress in rivet, D is equal to gross diameter of the rivet, diameter of the rivet hole, and T is equal to thickness of thinner plate in lap joint, या thickness of main plate or combined thickness of two cover plates, whichever is less in case of a butt joint. Last one is shearing strength of joints. So shearing strength of joint can be calculated by two ways, that is shearing strength of joint in single shear or shearing strength of rivet in double shear. So for single shear, the value of shearing strength of joint is equal to N into sigma VF into tau VF into pi D square over 4. Here N is equal to 1 for single riveted lap joint, N is equal to 2 for the double riveted lap or butt joint, N is equal to 3 for the single riveted lap or butt joint. Tau VF is equal to allowable shear stress in the rivet, and D is equal to gross diameter of the rivet. Same as for the double shear, shear strength of rivet in double shear, the value of PS is equal to 2 multiply the value of shear strength in single shear. That for double shear, same value multiplied by 2 for double shear. The formula is multiplied by a factor 2 because of double shear. Otherwise, the relation is same as in single shear. Next is considering full width of the joint. Full width of the joint means the complete width of the plate and the number of the rivets used in making the joints are known. So what considering full of the width, full width of the joint is, that is complete width of the plate and the number of the rivets used in making the joints. How we calculate the value of considering full width of the joint? In per pitch length of the joint, width is not known, therefore the number of rivets are taken in per pitch length. We calculate the value of tearing strength of plate, shearing strength of joint and bearing strength of a joint. Tearing strength of plate PT is equal to sigma AT into B minus ND into T. Here sigma AT is equal to allowable safe tensile strength and B is equal to width of the plate. N is equal to the number of the rivets in full width of the plate or joint. D is equal to gross diameter of the rivet. T is equal to thickness of the thinner plate in lap joint. For example, in case of a chain riveted joint, here width of the plate and number of rivets in the full plate is 1, 2, 3, 4, 5, 6. Here width of the plate B and here number of the rivet in full width of the plate is equal to 6. This is the example of a chain riveted lap joint. Next, in case of diamond riveted double cover butt joint. How we calculate the value of N? Here in 1 to 1 the value of N is equal to 1. In 2 to 2 the value of rivets is 2. In 3 to 3 the value of N is equal to 1, 2, 3. Put the value of N in this equation, we calculate the value of PT. Next is shearing strength of a joint, that is PS. How we calculate the value of PS? That is equal to the PS is equal to N into tau VF into pi d square over 4. That is for single shear. For double shear, multiply the same value by 2. For double shear, the value of PS is equal to 2 into N into tau VF into pi d square over 4. Here N is equal to the number of the rivets in the joint, D is equal to the gross diameter of the rivet, tau VF is equal to the allowable shear strength in rivet. Lastly, calculate the value of bearing strength of a joint. Bearing strength of the joint PB is equal to the N into sigma PF into D into T. Here N is equal to the number of the rivet, sigma PF is equal to the allowable bearing stress, D is equal to the gross diameter and T is equal to the thickness of the thinner plate. So value is the least of PB, PS and PT. Next is rivet value. Rivet value is defined as the maximum safe force one rivet can withstand. The strength of a rivet in shearing and bearing is calculated and the lesser value is taken as rivet value. The value of shearing and bearing strength one rivet can be calculated from the following relation. Shearing strength of one rivet, that is in single shear, is equal to tau Vf into pi d square over 4. For double shear, same value multiplied by 2. And the bearing strength of rivet is equal to sigma Pf into d into T. For a rivet value can be taken as least of equation 1 and equation 2. Next is efficiency of a riveted joint. The original strength of a structural sheet section is reduced by rivet holes provided in it. The efficiency of a rivet joint is the ratio of the strength of the material of the riveted joint to the strength of the solid plate. It is denoted by N and is expressed as percentage. The effectiveness of a particular riveted joint is measured by the efficiency. Mathematically, efficiency is expressed as strength of joint over strength of solid plate multiplied by 100. How we calculate the value of strength of a solid plate? Strength of solid plate is equal to sigma AT into P into T. And strength of the joint is equal to the least value of PB, PT and PS, as we earlier discussed. If we have to calculate the maximum efficiency can be achieved when the number of the holes are minimum at the critical section. Maximum efficiency can be calculated as P minus D over P into 100, where P is equal to the pitch of the rivet and D is equal to the gross diameter of the rivet. Next is permissible value of the stresses in the rivets. Here we showing a table in which the value of stress in rivets are written. Rivets in a power driven shop rivet, the value of shear stress is 100 Newton per mm square. For same, the value of bending stress is 300. For power-driven field rivet, value of shear stress, that is denoted by tau Vf, is 90 Newton per mm square, and for same, the value of bending moment, that is written as sigma Pf, the value is 270 Newton per mm square. Hand-driven rivet, the value of shear stress is 80 Newton per mm square, and value of bending stress is 250 Newton per mm square. The value of sigma 80, that is permissible tearing stress, is taken as 150 Newton per mm square. Here showing the value of permissible stresses in rivet that helps to calculate the value of shearing strength, rivet value and efficiency. In the end of the video, we will discuss the assumptions made in the analysis of a riveted joint. So what are the assumptions? First one is the friction between plates is neglected. The total load is uniformly distributed among all the rivets. Bearing stress is uniform between the contact surface of plate and rivets. Bending stress in the rivet is neglected. The tensile stress is uniformly distributed on the portion of the plate between the rivets. The rivets completely fill the rivet hole. The center of the gravity of the group of rivets is on the axis of the loading. For exam point of view, the assumptions made in the analysis of riveted joint are most asked question. In the next video, we will go with the problem based upon the strength, rivet value and efficiency. Hope you like the content of the video. For more video, like, share and subscribe my YouTube channel.